Alright guys, here we go. This is our second lesson in our review of Algebra 1, and in this lesson we're going to be solving inequalities. Our objective in this lesson is to solve and graph inequalities, and we are going to be interpreting solutions of inequalities. What that means is we're going to be writing those solutions in set builder and interval notation. This is part of our vocabulary for this lesson, so pause the video and write down the information or the vocabulary words and what they mean. If you need to, restart the video when you're done. Alright, this is the last of our vocabulary. This tells you what set builder and interval notation means as far as the definition goes. Write this down, see if you can understand it, and we'll be using it in our solutions, and hopefully by then you'll get the hang of it. Alright, this is just a little chart. I would advise, if I was you, I'd pause the video and write this information down. It is basically common phrases that when you take a written expression, such as a sentence, and change it into an algebraic expression, it tells you common words for these four inequalities. So pause the video now and write that down. Restart after you have that done. Alright, now I have some examples for us to quickly go through. First thing, when 1 and 2 are just one-step inequalities with addition and subtraction, you solve them just like you do an equation. So see if you remember, see what you remember from solving the equations. Pause the video now and see if you can solve these two inequalities, just number 1 and number 2. Alright, so here are my solutions for the one-step inequalities, 1 and 2. If you didn't get the same thing, check your work with mine. Remember, inequalities with addition and subtraction in one step, you do the exact same thing that you would do if you were solving an equation. But now let's look at 3 and 4. There is a difference between solving an equation and solving an inequality with multiplication and division. Whenever you multiply or divide both sides of the inequality by a negative number, you have to remember to flip direction of the inequality. So I'm going to go ahead and do number 3, 12b. Remember when I mentioned it on the previous lesson, coefficient, number attached to the variable, that means the math operation is multiplication. So to undo multiplication, I have to divide. If I divide one side, I divide the other. And I am dividing by the exact same thing I am multiplying. It is always dividing by the number in front of the variable. I divide both sides by 12. Now my 12 was positive. So that means that my inequality doesn't change. It was positive, so it points in the same direction. And finally, negative divided by positive, my answer is going to be negative, and 36 divided by 12 is 3. Alright, now my next problem. Number 4, this is division, and to undo division, I have to do multiplication. I do the opposite, but if you'll look here, I have a negative in front of here, so that means I have got to multiply, here's my multiplication symbol, most sides by a negative 4. Oops. Let me erase that because I straight about that wrong. Alright, so I'm multiplying by negative 4. Alright, over here, my 4's cancel out, and I am left with just the x, and I have the greater than, or, oops, let's leave that for just a minute, and I multiply my negative 4 by 7, which gives me negative 28. Now I multiplied by a negative number both sides, so what that means is I have to flip directions of my inequality to get my answer. If the number you are multiplying or dividing both sides of the inequality by is negative, you have to flip directions. That's the only difference between solving an equation and solving an inequality. Alright, our next example is a two-step inequality. Just like the one step, you solve a two-step inequality, just like you do a two-step equation. But the one difference you always got to remember is if you multiply or divide both sides by negative, and it's only with multiplication and division, you flip the inequality. So first of all, with this two-step, I have to undo my addition with subtraction. And that gives me negative plus negative. I'm at -9 on the number line, and I move 7 more in the negative direction. It puts me at -16. So now I have 2/5 W. To undo this multiplication of 2/5, I have to multiply by the reciprocal, which is 5/2. And what happens here is these cancel each other out, and I'm left with W. I still have my inequality because I did not multiply or divide by a negative number. And -16 times 5 is -80, and I divide that by 2, it's -40. So this is my solution. Alright, now we're going to add into this, with the solution, we're going to add into the graphing, the interval notation, and the set builder notation. Alright, a couple things to remember. Whenever you have an inequality and you graph it on a number line, this is from Algebra 1, if you have less than or greater than, that is an open circle. If you have less than or equal to and greater than or equal to, it is a closed circle. Alright, so your solution here, this is your starting point on your number line. So I am going to, you don't have to mark your whole number line. I'm just going to indicate -40 on the number line. And it is the or equal to. So that means I have a closed circle. Alright, now you always want your final answer, if you can, to have your variable on the left, your inequality, and then the number. Because when you have it in that pattern, your inequality is an arrow that points in the direction you shade. So I have a closed dot at -40, and I am shaded all the way to the arrow because my inequality points in the direction I shade. And here is one thing I like to do with my graph, which helps me at the interval notation. I like to write negative infinity above this arrow and positive infinity above this. Alright, so when I am doing my interval notation, basically I'm looking at my number line and I'm going with my shaded parts. Where does my shading start? Where does my shading stop? So I have my start point, my stop point. My shading starts on this arrow, and if you'll notice I've indicated up there, it's negative infinity. So my shading starts at negative infinity and it goes to -40 and it stops. Interval notation is always start point with the shading, comma, stop point. Alright, now for my notation around there. For interval notation, you're either going to use parentheses or a bracket. The only time you use a bracket is when you have a closed dot. So look, no closed dot on negative infinity, so it's a parentheses. Closed dot on -40, so it's a bracket. If that dot had been open, I'd have put a parentheses around -40. Alright, so now here's your format for set builder notation. It always goes into these squiggly brackets. Those squiggly brackets stand for the set of all real numbers. So we do our squiggly brackets, which means a set of all real numbers. Then we put our variable we're using. And then we draw this long slash here. And it stands for, mathematically, it stands for the word such that. So this reads the set of all numbers, W, such that, and then you just rewrite your inequality inside. And that is set builder notation. Alright, for this example, I want you to try this on your own. It's similar to what we did with the equations, it's just now it's an inequality. So then restart the video after you've solved the inequality before you do anything else and see if you're right at that point. So stop the video now and solve the inequality. Alright, so at this point you should have gotten your answer for your inequality is m is greater than -15. If you look back here, check your work with mind, if you didn't get what I did, check your work and look, I multiplied by a negative 2 times, or I multiplied by a negative once and divided by a negative once, so I actually flipped my inequality twice. So go back and check that. If you got that correct, I would like you to pause the video now and try to finish the graphing, interval notation, and set builder notation. Restart when you're done. Alright, so if you've checked your work, this should be what your graph looks like, your interval notation, and your set builder notation. If you're having trouble, write down a couple questions for yourself and we'll talk about it tomorrow. Alright, on this problem, I would like you to solve this inequality, and then once you get the inequality solved, I would like you to, let's see, I'd like you to pause the video, solve the inequality, then restart once you're done. So go ahead and pause the video now and restart when you've solved your inequality. Okay, so here's the solution I got when I solved this problem. I got 28 is less than negative 27. Is 28 less than negative 27? It is not. This is a false statement. Alright, if you get a false inequality, what that means is your answer to this is no solution. Or like I showed you before, the empty set with the empty set, the zeroth line through it. And if there is no solution, remember your graph is the shaded area that covers all solutions. So there is no graph, there is no interval notation, and your set builder notation is just the word no solution or the empty set. So if your inequality is false, there is no solution. So now, with that in mind, let's try the next problem. Okay folks, so this is the last problem for you to do, and I do notice a typo on here. I would like you to pay attention that that t should be a p, should have the same variable, so we're going to use p both times. So now I want you to, with that in mind, pause the video, solve this inequality, and then restart it when you have the inequality solved, and we'll talk about what that inequality means. Alright, so here's what happened when I solved this inequality. I got 24 is greater than or equal to negative 20. So is 24 greater than, bigger than negative 20? Yes, it is. So in this case, I get a true statement. When you get a true statement, what that means is your answer is all real numbers. And that's what this symbol stands for, like I told you in the last video. So when you graph a solution that has all real numbers, remember this arrow represents negative infinity. This one represents positive infinity. So when you shade, since it's all real numbers, that means every number on the number line is shaded. So it means the whole entire number line is shaded. And how this affects your interval notation is, remember it's just on the number line where my shading starts, comma, where my shading stops. So my shading starts at negative infinity, comma, and it goes to infinity. And remember, the only time I use a bracket is when there's a closed dot. Any other time, I use parentheses. No closed dot, so that means parentheses. Bracket means that number is included, a particular number. Infinity always has parentheses around it. And then for set builder notation, you can actually just use the all real number symbol again. Alright, that's it on solving inequalities.